So, guys, we're gonna talk about like terms. So in algebra, as we've said, we have the alphabets. You know, the letters of the alphabets. It could be A, it could be B, it could be C, all the way to Z. Those are all variables. Um, but in algebra, working the algebraic expressions, simplifying the algebraic expressions, you will come across an x and a y, and you have to simplify an x squared and a y squared, and you have to simplify. And the first step in doing that is about collecting all like terms, understanding what's a like term and what's not a like term. Consider the example they give in the book where you have coins. Um, so coins are not the same, coins are different. So what you want to do is to group terms together, add the ones that are alike together, um, and then come up with working them out that way. So that's the idea of like terms in algebra, really. It's really just about understanding what's like and what's the same. And what's like is really what's the same. An x squared will be put together with something like a 2x squared. So, for instance, x squared and a 2x squared will be like terms. So, you can add those, for instance. Or an x and an x, those will be like terms. They're addable together. Okay. Or if you had another like term, a y plus y squared would not be a like term. Okay. That's to the second degree, that's 1. So those are not addable together. It's like a 50 cents and I don't know, a 2 rand coin. So you don't do those together. Okay, just for us to get the idea of like terms before we get to actual expressions, I've got a table here, and the idea on this table, you've got something that looks like a triangle, you've got something that looks like a rectangle, you also have something that looks like a circle, and you have blank boxes. Okay, so what we do is when we're collecting like terms, I'll go around this and we'll do something different to each shape. That's the idea of like terms. So collecting like terms is doing something like this. So I'll choose to do something. So if we first start with the boxes that are empty, collect them as like terms. Do we have any in that row? No. Any in that one? We have one here. And for all the blank boxes, I will do that. Okay. I'm collecting like terms now. This would be the process of working with like terms in algebra. It's a bit abstract now, but when we get to example, you'll get to see the principle, okay? And then I will work out the O's, and I'll have a different process to the O's, to the circles. What I'll do is I'll just circle all those, okay? Those are different, okay? This is how I deal with them. I'm identifying, all I'm doing is I'm identifying shapes that are alike. I'm identifying shapes that are alike. They have identified shapes that are alike. Is there anything else that I'm missing? Okay, there isn't. Okay. So far, no, that is relevant really. Is I know I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've got 8 of these guys, and 2, 3, 4, and I've got 4 of these blank guys. Okay, that's the idea really of collecting like terms. Okay, I'm gonna find something that I need to do with the rectangles. Okay, rectangles. Maybe if I color the outsides, maybe that will work. It doesn't have to be perfect. I'm just showing what it would be to collect like terms. This is what the case would be if you're collecting. So there's my example of like terms. You're allocating like terms. Okay, now we're gonna look at examples. Okay, I see that I've got 5 rectangles, 8 circles and 4 of the blank blocks, and 1, 2, 3, 4, 5, 6, 7, 8. 8 of those kind of diamond shaped things. Okay, so that's the idea. I've collected all the like terms. So let's look at an example. What does this mean in example? Okay, so let's look at examples there. In the first example, we have 7 times x plus 3 times x plus x. We obviously have 3 terms there, and we have only one variable, which doesn't complicate things. And also this expression is only to 1 degree really. So you'll see what I mean. So the highest power, the highest exponent is only 1. So that's fine. So we don't have a lot of variation in it. So this should be simple. So we're going to go 7 times x is 7x. Okay. And then we're going to go plus 3 times x is 3x. Okay. Plus x. Right. Are these like terms or are they not like terms? Okay. In other words, we've got 7x's, we've got 3x's, and we've got 1x. Okay. Those are all like terms. That's the same thing. So that means we can go ahead and collect them together, like we would with 5 cents coins or whatever else is there, as long as it's alike. So 7x plus 3x plus x would be 11x. That would be our final answer. Okay, we've collected like terms. Let's look at B. 6abc minus 8bca plus 4acb.